Mars and Its Canals by Percival Lowell. Chapter 11. Vegetation. Since closer acquaintance takes from the Maria their character of the seas, we are led to inquire again to their constitution. Now, when we set ourselves to consider to what such appearances could be due, we note something besides sea, which forms a large part of our Earth's surface, and would have very much what we suppose the latter's aspect from afar to be, not only in tone, but in tint. This something is vegetation. Seen from a height and mellowed by atmospheric distance, great forests lose their green to become themselves ultramarine. To dispossess a previous conception is difficult, but so soon as we have put the idea of seas out of our heads, a vegetal explanation proves to satisfy the phenomena, even at a first glance, better than water surfaces. In their color, blue-green, the dark areas exactly typify the distant look of our own forests, whereas we are not at all sure that seas would. From color alone, we are more justified in deeming them vegetal than marine. But the moment we go further into the matter, the more certain we become of being upon the right road. With increased detection, the markings they reveal and the metamorphosis they undergo, while pointing away from water, point as directly to vegetation. All the inexplicabilities which the supposition of water involves find instant solution on the theory of vegetal growth. The non-balancing of the areas of shading in their shift from one part of the disk to another no longer becomes a circumstance impossible to explain, but a necessary consequence of their newfound character, denoting the time necessary for vegetation to sprout. The change of hue of vast areas from blue-green to ochre no longer presupposes the bodily transference of the thousands of tons of substances, but the quiet turning of the leaf under the autumnal frosts. Even the fact that they occupy those regions most fitted by figure to contain oceans fits in with the same conception. For that the Martian equivalents of forests and moorland, trees and grass, should grow now in the lowest parts of the planet's surface is what might not unreasonably be expected from the very fact of their being low, since what remained of the water would tend both on the surface and in the air to drain into them. For the change in question to be vegetal, it must occur at the proper season of the planet's year. This we must now consider. We have said that Schiaparelli detected change in the blue-green regions and suspected this change of seasonal affiliation. He inferred this from piecing together the aspects of different seasons of different years as shown in consecutive Martian oppositions. To mark it actually take place in a single Martian year came later. In 1894, at Flagstaff, the southern hemisphere was presented during its late spring and early summer. It was observed, too, for many of our months in succession. During this time, the planet was specially well circumstanced for study of the change in that hemisphere, both by reason of the appositeness of the season and of the unusual size of the disk. Advantage was taken of the double event to a recording of the consecutive appearances certain regions underwent, and the contrasted states thus exhibited were such as to clearly betoken the action of seasonal change. What Schiaparelli had thus ably inferred from diverse portions of different Martian years was in this case shown occurring in one and the same semestral cycle. Usually the change of hue seems essentially one of tone. The blue-green fades out, getting less and less pronounced, until in extreme cases only ochre is left behind. It acts as if the darker color were superimposed upon the lighter and could be, to a greater or lesser extent, removed. This is what Schiaparelli noted and what was seen in 1894 at Flagstaff. Three views en suite of the chain of changes then observed are shown in Mars, the region known as Hesperia being central in each. Comparison of the three discloses a remarkable metamorphosis in that promontory, a rise into visibility by a paling of its complexion. Nor is the contrast confined to it. Changes as salient will be noticed in the pictures over the other parts of the disk. There have been instances, however, of a metamorphosis so much more strange as to deserve exposition in detail. One where not tone simply is involved, but where a quite new tint has surprisingly appeared. On April 19th, 1903, when, after being hidden for 30 days, owing to the different rotation periods of the two planets, the Mare Erythraeum, the largest blue-green region of the disk, and laying in the southern hemisphere, rounded again into view, a startling transformation stood revealed in it. Instead of showing blue-green as usual, and as it had done 6 weeks before, it was now of a distinct chocolate brown. It had been well seen at its previous presentation, so that no doubt existed of its then tint. At that time, the Martian season corresponded to December 30 in our calendar. 18 Martian days had since elapsed, and it was now January 16 there. Metamorphosis had taken place, therefore, shortly after the winter solstice of that part of the planet, The color change that had supervened proved permanent. For the next night, the region showed the same brown hue, and so it continued to appear throughout the days that it was visible. 2 months passed, and then the chocolate hue had vanished, gone as it had come, and the mare had resumed its usual tint, except for being somewhat pale at the south. It had come to be February 21st on Mars. Timed and tabulated, the metamorphosis through which the mare passes stands out thus. Mare Erythraeum, 1903. Mundane date, February 16. After summer solstice, before equals minus, after equals plus, minus 10. Martian date, December 16. Aspect, blue-green. Mundane date, March 20. After summer solstice, plus 22. Martian date, January 1. Aspect, blue-green. Mundane date, April 19th. After summer solstice, plus 52. Martian date, January 16. Aspect, chocolate. Mundane date, April 22nd. After summer solstice, plus 55. Martian date, January 18. Aspect, chocolate. Mundane date, May 26. After summer solstice, plus 89. Martian date, February 4. Aspect, faint chocolate. Mundane date, May 30. After summer solstice, plus 123. Martian date, February 22. Aspect, faint blue-green. Mundane date, July 7. After summer solstice, plus 130. Martian date, February 25. Aspect, faint blue-green. The culmination of the transformation seems to have taken place about 60 days after the southern winter solstice, or in the depths of the Martian winter of that hemisphere. This is certainly just the time at which vegetation should be at its deadest. The northern and southern portions of the mare did not behave alike in taking on the chocolate tint. From the notes made about them during the opposition, it appears that the latter was later than the former in undergoing the metamorphosis, as will be seen from the following depth of the blue-green estimated in percentages shown at different dates, calling the deepest tone ever exhibited by it unity. Martian date, December 16, northern, 50%, southern, 50%. Martian date, January 1, northern, 50%, southern, 50%. Martian date, January 17, northern, 0%, southern, 0%. Martian date, February 5, northern, 25%, southern, 0%. Martian date, February 24, northern, 50%, southern, 25%. From this table, we may place the lowest point of the blue-green tint as reached about the 22nd day of January for the northern and the 5th of February for the southern part. This would indicate that the wave of returning growth came from the north, not the south, an important fact as we shall see later in studying the actions of the canals. At the next opposition, in 1905, a reoccurrence of the transformation was watched for, and not in vain. It occurred, however, somewhat later in the Martian season. On December 27 of the planet's current year, the Mare Erythraeum was still as usual, blue-green, nothing out of the ordinary being remarked in it, and so it was on its January 17, although the southern edge was darker than the northern. It looked certainly as if the metamorphosis were this year to be omitted, but such was not the case. When the region again came round on February 1 of the Martian calendar, there, the strange tint was as unmistakable as it had been on its original occurrence. Not only was the Mare Erythraeum so colored, but on February 5 Martian, the northern portion of the Mare Cimmerium was observed to be similarly affected. In the Mare Erythraeum, the anomalous chocolate hue was confined to a belt between the latitudes of 10 degrees and 20 degrees south of the equator. In the Mare Cimmerium, it stretched a little higher, from 10 degrees at the west to 25 degrees at the east. It is noteworthy that the southern portion of the latter showed blue at the time the northern showed brown. Then the metamorphosis proceeded as shown in the following table. Mare Erythraeum, 1905. Mundane date, January 25. Days after winter solstice of southern hemisphere. 12. Martian date, December 27. Aspect, blue-green. Mundane date, March 6. Days after winter solstice of southern hemisphere. 52. Martian date, January 16. Aspect, blue-green. Mundane date, April 4. Days after winter solstice of Southern Hemisphere, 81. Martian date, January 31. Aspect, chocolate. Mundane date, April 12. Days after winter solstice of Southern Hemisphere, 89. Martian date, February 4. Aspect, chocolate. Mundane date, April 30. Days after winter solstice of Southern Hemisphere, 107. Martian date, February 13. Aspect, faint chocolate. Mundane date, May 8th. Days after winter solstice of Southern Hemisphere, 115. Martian date, February 17. Aspect, faint chocolate. Mundane date, May 12th. Days after winter solstice of Southern Hemisphere, 119. Martian date, February 19. Aspect, faint blue-green. Mundane date, June 11. Days after winter solstice of Southern Hemisphere, 149. Martian date, March 6. Aspect, faint blue-green. Mundane date, June 15. Days after the winter solstice of the Southern Hemisphere, 153. Martian date, March 8. Aspect, faint blue-green. Mundane date, July 16. Days after the winter solstice of the Southern Hemisphere, 184. Martian date, March 23. Aspect, pale bluish green. Here, as in 1903, a chromatic rise and fall is evident. The culmination of the change occurring in March in early February, about 90 days after the winter solstice. That it was not of long duration is also indicated. If we examine the evidence for the two portions of the mare separately, the northern and the southern, as in 1903, we find it as follows. Martian date, December 27. Northern, 50%. Southern, 50%. Martian date, January 16. Northern, 50%. Southern, 50%. Martian date, February 2. Northern, 0%. Southern, 20%. Martian date, February 16. Northern, 10%. Southern, 20%. Martian date, March 7. Northern, 25%. Southern, 25%. Martian date, March 23. Northern, 30%. Southern, 30%. Here, again, a slight retardation in the advent of the metamorphosis is observable in the southern portion. There would seem to be a difference in the time of the change between the 2 years of 15 days, 1905 being that much the later. But with points of reference themselves 30 days apart, it is possible the two more nearly coincide than here appears. Unlike the ochre of the light regions generally, which suggests desert pure and simple, the chocolate brown precisely mimicked the complexion of fallow ground. When we consider the vegetal-like, blue-green, that it replaced, and remember further the time of year at which it occurred upon both these Martian years, we can hardly resist the conclusion that it was something very like fallow field that was there uncovered to our view. For the reoccurrence of the phenomena on 2 successive years, it is likely that it annually takes place. That it is seasonal can scarcely be doubted from the timeliness of its occurrence, and that different portions of its terrain successively underwent their metamorphosis shows further that it followed a law peculiar to the planet, to which we shall be introduced when we come to consider the phenomena of the canals. Instances of relative hue in different dark patches, corroboratory of seasonal variation and therefore of vegetal constitution, might easily be adduced. Thus, in 1905, during the summer of the northern hemisphere, the mare acetylum was notably darker than the mare erythraeum, to the north of it, which is what the law of seasonal variation would require, since it was June in the one, December in the other at the time. But we need not to add example to example or proof to proof, for there are no phenomena that could contradict it. We conclude, therefore, that the blue-green areas of Mars are not seas, but areas of vegetation. Just as reasoning to a negative result drifts us to the first conclusion, so reasoning to a positive one lands us at the second. End of section 12.